Good morning. We are discussing our second module, electrochemistry, that is electrochemical cells and energy storage systems. To start with electrochemistry. So what is electrochemistry? So electrochemistry is a separate branch of chemistry which deals with electrons. So in that majorly we are going to deal with electrochemical cells. So what are electrochemical cells? So electrochemical cells are devices which convert chemical energy into electrical energy and electrical energy into chemical energy. So electrochemical cells are the devices which convert chemical energy into electrical energy and vice versa. So this is the another alternative source for fossil fuels. So in our previous discussions we have discussed about fossil fuels, right? So now that is our first module. So other alternative source for fossil fuel cells are electrochemical cells, that is batteries. So in our electrochemical cells, the first thing is this, the cells which convert chemical energy into electrical energy. Those are called as galvanic cells. So electrochemical cells are two types. One is galvanic cell, other one is electrolytic cells. So what are galvanic cell? What is electrolytic cell? Let us discuss. So the device which converts chemical energy into electrical energy with redox reactions are known as galvanic cells. Example, Daniell cell. The other cell is electrolytic cell. The device which converts electrical energy into chemical energy, or with respect to, with use of electrical reactions, if chemical changes is brought about, then it is called as electrolytic cell. Example are electrolysis process, etc. Okay, so we are not going to deal much about electrolytic cell in this module. We are going to deal about galvanic cell. Okay, so the galvanic cell major example is Daniell cell. So before going in depth with galvanic cell, let us see what are the differences between galvanic cell and electrolytic cell. So galvanic cell, as we all know, it converts chemical energy into electrical energy, whereas electrolytic cells converts electrical energy into chemical energy. So in galvanic cell, anode is positive, electrolytic cell, anode is negative. In galvanic cell, cathode is negative. In electrolytic cell, cathode is positive. So the reactions are spontaneous in galvanic cell. Electrolytic cells, they require source of electrical energy to carry out non-spontaneous reactions. So galvanic cells, batteries, whereas electrolytic cell, electrolysis process. So let us see what is your Daniell cell. The best example for a galvanic cell is your Daniell cell. So in a Daniell cell, we have zinc dipped in zinc sulfate, copper dipped in copper sulfate solution. So we have two half cells. Daniell cell consists of two half cells. What is a half cell? Any metal dipped in its own salt solution constitutes a half cell. So Daniell cell constitutes two half cell. What are those? Zinc half cell and copper half cell. When zinc half cell and copper half cell are coupled together through a salt bridge and connected through voltmeter, it forms a cell. So any cell for this instance should have two half cells. So here we have two half cells, zinc dipped in zinc sulfate, copper dipped in copper sulfate. Okay, so when zinc is dipped in zinc sulfate, at zinc electrode oxidation occurs and at copper electrode reduction occurs. So you can see it below the zinc electrode, zinc is undergoing oxidation to give Zn, gives Zn2 plus and 2 electrons, and copper will accept 2 electrons to give Cu. Okay, so since zinc is termed as anode, whereas cathode is termed as cathode. Copper is termed as cathode. So zinc is negative electrode, cathode is positive electrode. As per IUPAC, the electrode where oxidation occurs is termed as anode, and the electrode where reduction occurs is termed as cathode. So this is named as, the terminology is as per IUPAC. Okay, IUPAC will be very familiar as per organic chemistry, right? So the electrode where oxidation occurs will be anode, and the electrode where reduction occurs will be cathode. So in a Daniell cell, oxidation occurs at zinc, therefore zinc is anode and is negatively charged, and at copper reduction occurs, therefore it is positively charged. So the same electrode can be represented. Okay, how it is represented? You can see below diagram there is a representation. The salt bridge is represented by two vertical lines. So left hand side of the salt bridge, you are going to write the cathodic, anodic representation, and on the right hand side you are going to write cathodic representation. So left hand side of the salt bridge is anode, right hand side of the salt bridge is cathode. So Zn slash ZnS4, that is Zn dipped in its own salt solution. Zn is the metal dipped in salt solution and salt bridge. Again here the cathodic electrode. That forms the representation of the cell. So here any metal which dipped in its own salt solution gives some potential. Okay. So for that instance, you have electrode potential, you have sad electrode potential, right? So what do you mean by electrode potential? So hereafter we are going to use these terminologies, right? So whenever a metal is dipped in its own salt solution, it's having a natural tendency to either lose or gain electrons, due to which a metal gains a potential which is simply known as electrode potential or single electrode potential. So whenever a metal is dipped in its own salt solution, it undergoes oxidation. What will happen? Zn gives Zn2 plus and 2 electrons. Zn2 plus will go into the electrolyte, and Zn2 plus will go into the electrolyte, and electrons will move towards the cathode. When electrons are moving towards the cathode, on the surface of the Zn, electrons will be deposited. Since on the surface of the electrode, electrons are deposited and Zn2 plus are in the solution, what will happen? There is a solution interface. Okay, metal solution interface. Since there is a metal solution interface, there will be negative and positive. So negative and positive will not get neutralized. There will be some force of attraction between the negative charge and positive charge. So due to that, the entire electrode will get some force, some charge. So that is called as what? Electrode potential. Okay, negative and positive, there will be some force of attraction. That is called as electrode potential. So the same electrode potential is measured at standard temperature, pressure and 1 molar concentration of the electrolyte. Then it is termed as standard electrode potential and it is denoted by E0. Okay. So next we have free energy. What do you mean by free energy? You might have heard Gibbs free energy, which is represented by delta G, right? So energy which can be converted, any energy which can be converted into useful work is known as Gibbs free, it's known as free energy. So it might be internal energy, or it might be external, or it might be both. So it is represented by delta G, that is Gibbs free energy, and is given by delta G equals delta H minus T delta S. So this delta G or the free energy might be 0, it can be negative, or it can be positive. It can be 0, or it can be lesser than 0, or it can be greater than 0. If it is lesser, if it is equal to 0, that implies that reaction is at equilibrium. If it is lesser than 0, it is negative. If delta G is lesser than 0, then reaction is spontaneous. If it is positive, that is delta G is greater than 0, then reaction is non-spontaneous. So similarly, we have entropy. So entropy is represented by delta S, right? So it is a measure of randomness or freeness or disorderness of the system. This delta entropy is applicable only for gases or liquids. So the entropy is very less, or 0 in the case of, less in the case of solids. If it is in liquid, it will increase, and the gaseous state, it will be higher. Okay, in gaseous state, entropy is higher and decreases from a gaseous state to liquid state, and still decreases in the solid state. So delta S, it is an extensive property. You have two types of property, intensive and extensive. So the property which depends on volume is called as extensive property, and the property which does not depend on volume is called as intensive property. So if delta S is equal to 0, then process is reversible. If delta S is greater than 0, process is irreversible. So these are the things which you are supposed to know, some terminologies which you are going to use in near future. So with this brief introduction, we'll start derivation of our Nernst equation in our next session. Thank you.